Hello, my name is Christopher Slagell, and I'm an applicant to the MSMS class of 2017, and this is my work sample. Now, to start, the title of my project is The Effects of Earthquakes on 3 Building Bases, and my project is about testing different forms of base isolation. Now, there are 2 reasons why I did this project. One is that I have interest in civil and mechanical engineering for my future, and 2, when it comes to natural disasters, there are several different ways to prepare for them. Like, for example, severe thunderstorms, you can hide inside a storm shelter, or with hurricanes and floods, you can evacuate the area to help protect yourself. However, when it comes to earthquakes, there are hardly any ways to prepare since they're so spontaneous and difficult to predict. Now, base isolation can help prevent damage from earthquakes. What base isolation is, it's the idea of putting a building on a surface to where it's not exactly touching the ground. What base isolation does is prevent movement and damage caused by earthquakes. And the main thing that I'm going to be testing in this project are the 3 primary forms of base isolation. These are rubber pads, springs, and rollers. And what I'm testing is to see which of these forms of base isolation will prove to be the best. Now, my hypothesis for the experiment stated that if the springs are the strongest and most flexible technique, then they will show to be the best form of base isolation. My materials I'll explain when I get to the procedure, and as for my variables, my independent variables were the 3 main forms of base isolation, the rubber pads, springs, and rollers. And my dependent variables were movement along the x-axis, movement along the y-axis, swaying of the building, and damage done to the building. Now, my first step in the procedure was building the earthquake generator. The method was found on the School Discovery Education website, and it required PVC pipe, wooden dowels, a wooden platform, rubber bands, eye bolts, and nuts. And the PVC pipe was arranged into a rectangular fashion with wooden dowels placed on top. Then the eye bolts were screwed into the sides of the PVC pipe with rubber bands attaching it to the then the wooden platform that was placed on top. The second step in my procedure was building the model building. This was done doing a custom method that I had. It required shoe boxes, duct tape, glue, spray paint, fishing string, and a wooden platform. Now, I stacked the shoe boxes from biggest to smallest, and I then attached everything together with duct tape and glue to make sure everything was secure. And also for the fishing string, it's important to mention that I applied cross bracing in an X fashion down the inside of the building to provide internal structure. Alright, now for my set of experiments I conducted, the first experiment was with the rubber pads. I simply applied the rubber pad base and performed 3 trials. For the next experiment, the second experiment, the springs, I detached the rubber pads and applied the springs, performed 3 trials. The same was done for the third experiment and with the rollers, which I detached the springs and applied the rollers and performed 3 trials. Now, it's important to mention that for each trial, the building's original placement was marked, and the movement along the X and Y axis, along with swing and damage done to the building, were recorded. And for my research, there are 3 main factors to take into effect when it comes to earthquakes. These are the 3 main types of waves that are created from them. These are P waves, S waves, and L waves. The first type, P waves, are primary waves or pressure waves. These cause up and down movement and are not very powerful. The second type of wave, the S waves, or secondary waves or shear waves, they cause horizontal movement and are moderately powerful. The third and final type of wave, the L waves or surface waves, they cause a wave-like or rolling motion atop on the top of the crust, and these are the most powerful type of waves. These are the ones that destroy cities and buildings, etc., and are the ones that you mainly need to watch out for. Now, base isolation is very important because it can prevent up to 75% of the movement caused by these 3 waves. That's exactly why I'm doing this experiment, because base isolation is the most important and best way to prevent damage and movement caused by earthquakes. Alright, now for my data, you can see the averages table. Now this is the main table that I used for my results and my conclusion. As you can see movement along the X and Y axis in comparison with the rubber pads, springs, and rollers. You can see that the rollers had significantly less movement than the rubber pads and a little bit less movement than the springs. You can also see that since these are forms of base isolation, absolutely no damage was done to the building through all three experiments. For the rubber pads, you can see the growth and decay along the X and Y axis. This chart goes from 0 to 10 inches. As you can see, there was a lot of movement along the Y axis. And for the springs chart, you can see that there's either the growth either stays the same or decays a little bit. For the movement along the X and Y axis, this chart is also from 0 to 10 inches. And finally, for the rollers chart, you can see that it's from 0 to 2 inches, and that's significantly lower because there wasn't nearly as much growth or decay with the rollers and the movement along the X and Y axis. Now finally, for the averages bar graph, this is basically to visualize the averages table and show you with visual how big of a difference there were between the three different forms of base isolations. And as for my pictures, the first picture shows the rubber pad base before shaken. The second picture shows the rubber pads after being shaken, and you can see how much movement existed with that first trial. The third picture shows the spring base before it was shaken, and the fourth picture shows the roller base. Finally, for my conclusion, my results do not support my hypothesis due to the fact that the rollers proved to be the most effective form of base isolation. And this is probably due to the fact that it was the most complex technique. It had two levels to it, as the springs and the rubber pads only had one level to them. If I were to improve this project in the future, there's several things I could do. One would be to change the environment. I tested this on a floor, which is a flat surface. I could also test it on a slanted surface, or maybe sand, or some sort of suspension over water that could affect what form of base isolation would be the most effective. Another thing I could do would be to research non-traditional methods of base isolation and test those in comparison with the three primary forms of base isolation. Another thing I could do would be test multiple buildings. The building that I used was fairly tall in comparison with the earthquake generator. I could test wider buildings, I could test different materials instead of cardboard, I could test taller buildings that could affect which form of base isolation is the most effective. And finally, it's always good to perform more trials. I performed 3 trials for each experiment, and I could perform 5 or 10 or however many that I wanted to perform. No matter how many more I performed, it would always make the data more accurate. All right, my name is Christopher Slagell, and this is my work sample presentation.